So we're going to talk about even and odd functions today. I wanted to just give you the definitions real quick and then kind of give you some idea of what this says because it seems pretty bad when you first read it. So it says f is an even function if f of opposite x is the same as f of x. So this is not negative x, it's opposite. Um, so we'll look at these in a second. So here's the second idea. F is an odd function if f of opposite x is equal to the opposite of f of x. So the first one is symmetrical to the y-axis. Odd functions are symmetrical to the origin. So let's take a look at this for a second. I think it will make some sense. Let's take a look and let's try to find out if a function is even or odd. So let's take this function here. This little experiment. So let's take f of x is equal to 3x to the fourth power minus 2x squared plus 5. And what we want to know is that an even or odd function? So let's find out what happens here. So we know that this is going to be an even function if f of opposite x is the same as f of x, right? So it's going to do this test. So what I'm going to do is I'm going to take f of opposite x here. Let me do it in this color. F of opposite x here. So if you don't mind, I'm going to have this 3 to the fourth minus 2x squared plus 5. And just go do our substitution here and put in opposite here. But look what happens. Let's see what happens here. Negative x to the fourth is just x to the fourth, isn't it? So we get 3x to the fourth minus, right? Negative x squared is just x, and negative 2 times x is negative 2x squared, isn't it? Right? Plus 5 is equal to f of x. So here we have this. The condition is met here. And what this would look like is, I guess a really easy example of this would be to look at it like this. Let's say for an even function, let's set f of x equal just x squared, and say it's symmetrical to the y-axis, right? Well, let's say plus 1, just to. Okay, so it would look something like this, wouldn't it? Like this, and like this, and we have the point here. Right, this point here is the exact opposite, but the exact opposite here has the same height as here, doesn't it? If we fill in the blanks, so these would be straight across each other, right? Okay, let's try one more, just check out how this might work. Now let's try this function. So even or odd, right? That's our question here. F of x is equal to x cubed plus x squared. So what we're going to do again is we're going to take f of opposite x here, which would give us cubed plus right? Well, look at this. This is really cool, isn't it? Yeah, I just got stuck for a second because this is going to go to negative, right? This is going to go to negative x cubed. That's looking really good for an odd function, isn't it? But this is going to go to plus x. I'm sorry, yeah, to plus x squared. So it's not going to be the perfect opposite, is it? So this is neither even nor odd. Let's try to take one more really quick. Hopefully you're still with me. Let's find one that is odd. How about this one? Let's take this. Let's try this one. Let f of x equal 2x to the fifth plus, minus 7x cubed plus 4x. Same thing we did last time. We're going to do this time. We're going to take f of opposite x is equal to 2 times opposite x to the fifth minus 7 opposite x cubed plus 4 times opposite x, right? Do all this math, and we're going to get, right, we're going to get negative 2x to the fifth, aren't we? Right? Positive 7x cubed right. Minus 4x. So it does equal opposite, doesn't it? That's awesome. Okay, so this is an odd function, right? Because we know that the rule is f of opposite x has got to equal the opposite of f of x. And these are opposites everywhere, right? This was a positive, this is a negative, this is a negative, this is a positive, this was a positive, this is a negative. So it's perfect opposite, isn't it? Okay, so we did it. Good job.